Right, so welcome to Cyber Back to School, and welcome to the session called Cybercrime as Big Data, where I explain how cybercrime can be thought of as big data and vice versa. So I should probably introduce myself first before we begin. So, as you can probably tell, my name is Lukas. I run a blog at lucasvileikis.com. I'm the founder of the data breach search engine over breachdirectory.com that enables you to check whether your identity is at risk of identity theft by searching through a bunch of data breaches. I wrote a book that you can see on the left hand side called Hacking MySQL, Breaking, Optimizing and Securing MySQL for Your Use Case. And I am also an avid conference speaker. I spoke at Percona Live, MariaDB Serverfest, Nerdola, DevTalks, Build Stuff, Big Data Conference, and as you can see, I am speaking in this event right now. I can be contacted via the email that you see on the screen, and the link that you see on the bottom right side enables me to get feedback from you to improve my talks in the future. So if you would like to, I would like to ask for a minute of your time to fill out the form and tell what went wrong in my speech and how I can improve as a speaker, and whether you liked it or not. And with that being said, let's begin. So what is cybercrime, right? So cybercrime is a thing that everybody knows, but nobody really thinks about until it's too late. So usually people think of cybercrime when they find their data in data breach search engines, such as breachdirectory.com that I run, that you can see on the screen right now. Such data breach search engines enable you to search for email addresses, usernames, domain, IP addresses, or any other classes of data to figure out whether you've been exposed in a data breach. And they have a very strong point to make, because what they're trying to do is that they're trying to tell people that if you build software, you should probably write secure code before your data appears in data breach search engine. Because when people build software, they usually don't think about, cybercrime or what's going to happen when my data gets breached or whatever. People follow secure coding practices, but they still get breached because they miss certain small things, right? Or maybe they don't encrypt data in some sort of a fashion, or maybe they don't do other things as well, or maybe they get social engineered, right? So the second phase after you build software is something people think of as a magical thing that happens, and then after that the data appears in data breach search engines. But actually it's not at all magical. It's actually very easy to understand, and in this speech we're gonna talk about how it can be understood, why cybercrime happens and how it happens, why should you care, what happens to your applications and database when they become victims of cybercrime, how it transforms into big data, what to do with big data in your database in some corner cases, and I will also talk about how can you avoid being breached if you build applications. So in essence, any of you who build applications did probably hear about data breaches at some point, either now or in the future. So what you see on the screen right now is my data breach search engine, that if you provide an email address, a username, or something else, it tells you whether your account is at risk of identity theft. And the core purpose of this is that it tells you, depicting all of the data breaches that contain your any data class that you provided to the data breach search engine. And it also tells you how many people are in danger, when the data breach happened, what data was compromised, and so on and so on. But before that happens, your data must be insecure, right? So that happens, data ends up in data breach search engines because you write insecure code. Your code may be susceptible to cross-site scripting, as you can see on the fourth line right now. It may be susceptible to SQL injection, as you can see on the fifth line right now, or maybe you can do a bunch of other things that make it susceptible to other kinds of attacks. For example, as you can see on the seventh line, we redirect to a URL provided by the user, which is also open redirect attack. And we also don't exit after providing the header, which means that PHP will continue serving the rest of the page, and this is generally not recommended. So there's a bunch of flaws. There's 3 flaws in pretty much 7 lines of code. And this is how data breaches happen, because people exploit those flaws. And when those flaws are exploited, people usually gain access to your database. Why do they gain access to the database? Now, for most of you, for developers, for security engineers, the reasons are quite clear. And the reason why is pretty simple and straightforward. This is a screenshot from 2015, but this gets the point across very clearly. Your data is valuable. Data is stolen because then data is resold on some black markets, on some dark web markets. And this site is in particular, this was in 2015, which is why you see such prices in Bitcoin. This was accessible over the clear web, and it wasn't even a hidden website or something like that. So people could basically access this website, and they could purchase anything they wanted to for a couple of Bitcoin or half a Bitcoin, any data they wanted to, and they would use the data to further mount any theft attacks and to facilitate cybercrime further. And as their data collection grows, the attacks they can mount also grow, and so the cycle repeats. Right, so when you build applications, let's say you are building maybe a car listing, right? So maybe a car searching website or something like that. So in 2015, maybe you have 5,000 car details, right? In 2017, you maybe do a lot of research and a lot of people contribute to your website, maybe, and you have 5 million cars that people can search through when, I don't know, when facing car-related problems or when purchasing cars or whatever. In 2021, maybe your application explodes and then you have 500 million records. In 2025, you have 10 billion cars on the record and everyone using it. Maybe you're building the next Facebook, But when some time comes, you will also need to think about data breach. So in one of those phases, you probably will suffer a data breach, or at least someone will try to turn your application into a testing ground for their nefarious activities, right? And this is why you need to think of standards like NIST, GDPR, OWASP Top 10, or something else. So if you are an in-person business, you also need to think about social engineering, because when some guy comes in, maybe you need to automatically screen him for his maybe nefarious intentions, right? So and so on and so on. But it also all begins with data in your database. So with the data classes, so you need to use the need to know principle, where less data that is stored is less data that is stolen. And you also need to assume that everything is breached, because with such an assumption it's more easy for you to understand the scope of your application and better protect your users. And when you work with data, you need to follow, as I already said, secure coding practices. You need to follow, obviously, the basics. Don't provide user input to the database, because that's called injection. Don't echo user input out, because that's reflective cross-site scripting and stuff like that. And maybe there is some things that you need to keep secret, right? So maybe you are using login location that you need to keep secret from prying eyes. Maybe you have an administrative location in one place on your website, but the real administrative location is on the other side, and you use it as a honeypot. I've seen that done as well. So you may also need to stay silent, and also you may consider using firewalls that may produce false positives, but in general firewalls are a very good thing to protect your data in any scenario, whatever you may use. So in regards to errors, you need to think of them as well. there's a saying that the best error message is the one that never shows up. I don't really know who said that, but there is a quote from someone on the web, right? And the reason, I think the context why this thing was said was because the error messages, they often provide you with data that they shouldn't be providing, right? They may be providing sensitive user directories, sensitive script locations, or something like that. Or maybe the error message will say something inexplicitly that hints of there being security error or something like that. So to prevent all this, you need to, in general, follow a couple of things. 4 things are a good place to start. So first, you need to sanitize user input. No matter how many data you have, either it's big, no matter it's big data, like a billion rows, or maybe a smaller set of data like 1,000 or even 100, you always need to sanitize user input, because if you provide user input straight to the database, you're just asking for trouble. And also follow other security guidelines. You need to evaluate your audience, who uses your product and why and how do they do it, so that if you know who uses your audience, you know what's the use case of your application and what happens after what, so you can use preventative measures to protect these steps. And also you need to conduct security training. If you run a company, it's actually not a very unusual thing. Many companies actually conduct security training. Some do so regularly, every 3-6 months, or even more often. And those security trainings ensure that employees won't fall victims to attacks if they are prepared for them. So if you run a mock phishing attack and it fails, you know that your employees are well secured and well prepared for phishing attacks. And also there may be consequences for also not complying or failing such tests, and so on and so on. So you need to talk to those people, you need to educate them, you need to teach them how certain things work, and so on and so on. And after you teach them, you are able to avoid cybercrime. So another thing that helps you actually avoid cybercrime and is incredibly useful is data breach search engines. So as I already told you, the reason, the thing that you see here on the screen is a data breach search engine available at breachdirectory.com that I have built. It's based on MariaDB, and it houses hundreds of data breaches and tens of billions of records at this point. It doesn't log any searches, but it helps you figure out whether your account details are in danger. So whether you search for email addresses, usernames, website domains, or IP addresses, or maybe website titles, it tells you what kind of data class is in danger and what data is stolen, how many records are stolen, how the data breach happened, and how to better protect yourself. It also has an API appliance that is actually very widely used, and it's used by universities, individuals, companies, and so on and so on. And the reason why it's used is because the API provides the data from the data breach search engine, so that the data can be taken and then used in some kind of capacity to protect other people. So I highly recommend you using it. I have, as you can see, over 20 million people already used it, and majority of them already liked it very much. So this is why I'm immensely proud of, and I hope you will make use of it as well. It can be found at breachdirectory.com, and the use of it is, in most cases, absolutely free and doesn't cost you anything. What it does cost you is providing some feedback for this talk so I can improve. So you can head over to my website /feedback.php, where you'll be redirected to a form, to a Google form, where I will ask for a minute of your time to tell me what went wrong in my speech, how I can improve as a speaker, and what would you like to see me talk about next. You can also find me on LinkedIn, on Twitter. I have a personal website, and I invite you to follow breachdirectory.com as well. You can also reach me via email if you want to talk to me, you can either mail me at my personal address or you can mail me at lukas@breachdirectory.com. I usually like to talk, and I hope you enjoyed the speech. So thank you very much, and I hope you enjoyed, and I hope you learned something new. Thank you.